Hello everyone, good afternoon. Uh, Thanks for having us. It is a pleasure to be here today. This is my first ever KubeCon, my first ever trip to China, to Shanghai of course, and also my first... Okay, sorry. Did you guys catch any of that previously? Okay, wait. Okay, I'll just hold it in my hand. Okay. Yeah, hello everyone. Thanks for having us. This is my first ever KubeCon, also my first ever trip to China, and my first ever trip to Shanghai, of course. This is my first ever time to having to use VPN to access Twitter, my work email, and etc. So it's new experience to me. Okay, so today we are going to talk about Kubernetes on supporting 1 million bike taxi drivers in Indonesia. So first let me introduce ourselves. My name is Iqbal Farabi, and my friend here is Giri Kuncoro. Yeah, we are both are engineers from GO-JEK Indonesia. So most of you probably have not really been familiar with GO-JEK. So let me introduce GO-JEK first as well. So we are from Jakarta, Indonesia. Anyone has ever been to Jakarta before? Okay, 2 people, good. So if you have been to Jakarta, you might be familiar with this image right here. Yeah. So Jakarta, we have a serious problem with our traffic there. So this is what it looks like in Jakarta main streets in rush hours. So our traffic jam is basically dysfunctional, and so lately this has been like this for not in rush hours as well. I mean, almost every time. But we Jakarta, we are a bunch of resilient people. So the lack of public infrastructure enabled us to instead develop our own transportation mode. Back then we call it OJEK. So what is an OJEK, you might wonder? An OJEK is this is, I don't think you have this in China. Yeah, this is it looks like this. So it is actually like a bike taxi. So like people will drive a bike and then you can rent they can pick you up and then ride you to some places. But it only works for short trips. As you might wonder, it comes with a lot of like problems because it doesn't really serve the public effectively. So in 2010, Nadiem Makarim, our CEO and the co-founder of GO-JEK, he created something that he called GO-JEK. So what is GO-JEK? So at the time, GO-JEK only serves as a call center. Basically, you can call GO-JEK and you ask them to find you a bike taxi driver. And then what it does, it only let's say matchmaking you into bike taxi drivers. And of course, obviously it did not take off because such a service is very limited in its scope and in what it can serve. But then something happened in 2015. The adoption of mobile phone, smartphones, especially Android phones, have become very ubiquitous in Indonesia. So this is the period in which most Indonesians can afford to buy Android phones. And then GO-JEK launched its first mobile app in 2015. So it started with 3 services. The first 3 icon in the slide, in the screen that you can see. First is GoRide. Of course, it is a bike taxi that the second one is GoMart. It is if you want to have your grocery sent to your home or some address, you can use GoMart. And then GoSend is to basically send small items from one point to another. It starts with this 3 humble service, but in the span of 3 years, from 2015 to 2017, GO-JEK has become a big service in Indonesia. We have at least 18 services, if I count correctly. I don't really remember the correct number, the exact number. So we have, and some of our services are the market leader in Indonesia. So for instance, we have GoFood. GoFood is the biggest delivery service. I think I don't know, in the world, outside of China, of course, because China have much more people than us. It's not fair. So, but we are bigger than all delivery service in India combined. So the 3 delivery service in India, Zomato, Swiggy, and Uber Food. Yeah, we are bigger than that. And then we have GoPay, the blue wallet that you can see right there. It's the biggest e-wallet service in Indonesia. Of course, our GoRide, our riding services as well, combined, we serve more than 1 million services per day. No. Sorry, 100 million services per day. And then we went from only a handful of drivers. Back then, in 2010, it was just probably around 20 to 40 drivers into 1 million drivers today. In 2018, GO-JEK acquired 3 financial technology companies in Indonesia. One of the first one is Midtrans. It is one of the largest online payment service in Indonesia. The second one is Kartuku. It is one of the largest offline payment service in Indonesia. And then the third one is Mapan. It is one of the largest financial service for the unbanked in Indonesia. So we also just recently, 2 months ago, we launched our service in Vietnam. It's called GoViet. We are now in beta, I think. Am I correct? In Thailand, beta version, and then we are going to launch soon in Singapore. So yeah, that's the story of GO-JEK. Of course, with this great growth and great number of apps comes a great headache. So I will show you a typical workflow of an app in GO-JEK. So this is an anonymized architecture of microservices involved in processing a single order in GoPay, our e-wallet service. So all of this should happen in order of less than 3 to 5 seconds. Otherwise, the customer will get upset. So we have some services, we have some workers, we have some reading and writing to and from Kafka, and then reading and writing to and from database. Of course, managing this many services could be a nightmare. Even the stories thought that in our dark days, early days, it takes for engineers to have their infrastructure ready, it takes like a week. But that was dark ages. We are way past that. So what we did was we tried to automate everything, obviously. We went with infrastructure as code. We went with Terraform, Chef, and Ansible. But in the span 3 years from 2015 to 2017, we created enough Terraform modules, Ansible playbooks, and Chef cookbooks to automate most of GO-JEK use cases. So we went from 3 VMs in 2015 to more than 10,000 VMs today. Yeah, but that's of course not the story that you are looking for, because you want to hear the story about our Kubernetes journey. And Giri here will tell you the story.
So okay, thank you. So by keeping this in mind, we began our GO-JEK journey to the land of containers. This is a typical picture that you would see. There's a bunch of containers there being shipped by, what do you call that, ship? Okay. So anyway, we decided to migrate from VMs to containers because of typical 3 advantages that containers can bring, right? First thing is by adopting containers in our infrastructure, we would be able to reduce the amount of VMs that we manage and eventually reduce the infrastructure costs of the entire organization. And then second, we would be able to speed up much faster the iteration of the developers on development, testing, deployment of their application and services. And then lastly, by adopting the containers, we hope that we could react much faster whenever there are traffic spikes. Because spinning up containers is definitely much faster than spinning up new VMs to support the spikes workload in our infrastructure. So by late 2016, in order to start up our container migration effort, we started a new project called ProjectX. I know it's not a fancy name here, but we could not find a better name in 10 days, so we just stick with X here. So at that time, as an entire organization, obviously we were very new at that time to containers and container orchestration system. So we envisioned Project X to enable the product engineers or developers to create their applications easily in our container-based infrastructure. We envision Project X so that the developers could similarly, the expression would be similar to creating applications on Heroku, for instance. And then by abstracting away the complexity of containers and container orchestration system from developer perspective, we hope that developers don't have to gain the knowledge of container and container orchestration system here. When we designed first the Project X, we were also new. As part of the infrastructure team, we were actually very small. And we were new, so we were not only looking on Kubernetes at that time, we were looking on Mesos as well, and Nomad to help us in deploying container application. So we hope to learn as we go. We decided that Project X could deploy in both Kubernetes and Nomad infrastructure. Here's a typical workflow that a developer will face whenever they wanted to deploy their application. So they will go to Project X Web UI or CLI and then configure their metadata, whatever information required on their application. And then Project X will generate something called Gerald manifest, which is a generic manifest which represents our infrastructure, container-based infrastructure in this case. And then Project X will package the applications into a container and then push to Docker registry. In this case, Project X will generate, in this case, depending on the choice, either Kubernetes or Nomad manifest, and then deploy to, depending on the choice, Kubernetes or Nomad infrastructure. So the idea here, developers did not have to care where their applications were running. That was the idea. And then we, as an infrastructure team, we had a privilege to mandate everyone to migrate to this new tooling. And then we started rolling out. What happened at that time? It went very badly. We faced a lot of issues in both technical as well as non-technical issues. At least we faced 3 technical issues here. First, Project X did not have a well-designed abstraction because obviously we were trying to make a super generic abstraction that are good for both Kubernetes and Nomad in this case. So the implication of this is Project X was not easily extendable. As you guys know, the Kubernetes community is actually very dynamic and very fast-paced. There's always really something new every 3 months, and probably every week there's always new patches or new bug fixes, something like that. So this makes it hard to adopt the changes that community bring to our toolings. And then last thing, we tried to abstract too much so that this deployment tool became a black box, for the developers. So most of the time, whenever there are production issues arise or deployment issues arise, they always blame us. They always blame us, the infrastructure team, and blame the Project X, whereas the real issue most of the time are in the Kubernetes configuration itself, for example. And then we, the mistake at that time, we did not give capability to developers to see their application logs because of this as well. That was one of the biggest complaints coming from the developers. Apart from technical issues, we were also facing at least 2 non-technical issues. At that time, the knowledge was new, right? The entire organization was new. We were pretty small at that time. The migration effort was to centralize within the small infrastructure team, and the knowledge that we were trying to gain from the community was siloed within that single team only. So we could not keep the learning pace with the changes in the community and the knowledge. And then the biggest mistake was starting to roll out with a bang. So we mandated everyone, all teams in the company, to migrate at one time instead of onboarding small number of teams at a time. So the result of this is multiple issues were raised by multiple teams at the same time. And since we were very small, we did not have any bandwidth to squash all the bugs, iterate and move on, and things like that. However, not all is vain. In winning, we earn. In losing, we learn. We do learn from all of our mistakes. So from the mistakes, we decided to decentralize. Instead of centralizing the migration effort, we decentralize the VM to container migration effort to all the teams. So the implication of this is some teams have different approaches. A lot of approaches are raised. However, in a run-well organization, best ideas will eventually converge. So as I told you, there are multiple approaches here. Some teams decided to run container workload in AWS, running on Kubernetes cluster deployed by ops. For example, for their specific teams, they were using, for instance, AWS CNI plugin because they had a hybrid workload. They had an external VM-based Consul cluster, for instance, for their service discovery. So the external cluster could discover the pods directly through the routable IPs. Some teams are running containerized workloads on a managed Kubernetes by Google Cloud or in GKE. Some teams, because of compliance, in particular, the payment team or Group A team, e-wallet service team, runs Kubernetes cluster on-premise using kubeadm, and KVM and libvirt-based baremetal machine, and some of the workloads are also running on vSphere, actually. Deployment-wise, some teams decided to use Helm to package their application into Helm charts and then deploy using Helm within their CI/CD. They didn't use ProjectX. Some teams actually built their own custom controller using Kube Builder called White Rabbit. This was there because they have a specific use case to have multiple deployments at the same time for serving one single application. This is a good use case in our data science infrastructure team because they wanted to test multiple different predictive models, for instance, for one single application to test which one works best for particular use case or customers. And then from the mistakes, we could improve our ProjectX-based deployment tool. We decided to focus on Kubernetes only. We threw away a Nomad. And then with this, we were able to refactor our abstractions into much better design so that we could patch our things here much faster whenever there are new features offered in upstream community. And then we decided to do staggered rollout across the entire organization. We work with small number of teams at a time, and then fix issues there, iterate, and then move on, and then onboard another team. As a result of this, ProjectX has become a primary deployment tool for our GO-JEK international expansion projects. As Iqbal mentioned earlier, we just launched GO-JEK services in Vietnam, and then we will be launching in Singapore in a few weeks, and Thailand soon, very soon. Because of adopting the containers and Kubernetes, we were able to set up Vietnam infrastructure much faster. It took us only 4 days to set up from scratch, really scratch, there in Vietnam. And then because of this, this is, by the way, called cookie cutter model. Because of the portability nature that Kubernetes offered, we were able to repeat or basically replicate the infrastructure to run the whole business very quickly. For instance, here we launched in Vietnam. It took us very fast, and then we were able to, because Kubernetes is very portable, we will be able to create Thailand infrastructure from scratch fast as well. And then at our scale, today we are actually processing 3 million orders daily. with at least 400 microservices. At our scale, because of Kubernetes and containers, we would be able to scale our business growth very well. And then lastly, by adopting Kubernetes, we are able to support faster mean time to recovery here, because Kubernetes always does the health checking thing and then make sure it does auto scale and stuff. We were also running stateful services on Kubernetes in Vietnam here. As a result, the DBs had much fewer outage and improved their reliability. And then with containers, we improve our CPU utilization and memory utilization, became very efficient. Then we extended ProjectX with some central config management with namespaces to enable easy multi-deployment and multi-data center. And then finally, the most important one, we could save up to 60% infrastructure costs per year per country in Vietnam case. If we did not adopt container from the beginning, we would have been easily deployed thousands of VMs there in Vietnam. Iqbal is going to talk about our logging infrastructure.
Yeah, as Giri mentioned earlier, one of the problem that we faced when we were launching with ProjectX is that ProjectX itself became a black box for our product engineers. It is problematic because when things went wrong, our product engineers will not be able to figure out what went wrong. So we created a centralized logging system called Burrito Lock. So the picture you see here is the Burrito River in Indonesia. So what people do in Burrito River is they transport a wood log from the forest to the city, and then they have like floating market. This is very beautiful actually. If you have a chance to go to Kalimantan, you can see this Burrito floating market in Burrito River. So this is actually something that deserves its own in-depth talk. So I will just only touch the overview of this. So what is Burrito Lock? So actually it has several elements, and of course it utilizes several CNCF projects. So in the market, what a product engineers can do is they can register their services there, and then once they register their services there, Burrito Lock will install an agent in their services, and then with the router, Burrito Lock will be able to route their logging data from their services into several log clusters. So, for instance, in here there is a log cluster A, and then once the log is received, this log will be kept by a Burrito producer that will produce Kafka topics, and then it will be consumed by Burrito Lock consumer, and then it will be passed to Elasticsearch, and then will be displayed through Kibana. So that's the overall overview of how Burrito Lock works. So that's what so far. Now Burrito Lock has been in production since I think several months ago, and then right now we are even past the 1,000 transactions per second, and if I recall correctly, at one time we had trouble with this, and we consult several people and find out that I think Google App Stack driver is only processing less than that, but I don't know. My point is that the scale in which Burrito Lock is operating is actually quite interesting, and I really hope that our colleagues who work on Burrito Lock will be able to submit this as CFP for the next KubeCon. Yeah. The other problem that Giri mentioned earlier is that the knowledge about containers and cloud native applications and Kubernetes became siloed in one particular team at the time when we launched ProjectX, and it is not good. We are not saying that centralized effort will always be bad. In fact, for Burrito Lock, we are doing centralized effort there. But what we are saying that when knowledge of a particular technology that our organization is adopting siloed into one only handful of people, it is not good. So another remedy that we took is that we create a session called Cloud Native Saturdays. This is basically knowledge sharing sessions that we conduct every Saturday within our organization. The goal of this session is to be able to spread the knowledge of cloud native applications, of course, cloud native technologies, of course, including Kubernetes and all the CNCF projects to the whole organization. Okay, and then next.
We have been running 100% container workload in Vietnam on Kubernetes. And then we have been also running 100% containerized workload for data science infrastructure. But at current state, we are still in the middle of migrating the entire existing production traffic. So we might be able to share that learnings next year, hopefully. And then the next thing is we are looking into migrating stateful applications as well. We have proven that running DB services in Vietnam improve reliability on Kubernetes. So next, we are looking into Minio to transform Kubernetes PVs into something like object storage S3 to store our massive amount of KYC images, for example, and our driver profile pictures, for example, because of compliance reason. And we are actually adopting Stolon. We have our own fork of Stolon. If you guys don't know Stolon, Stolon will help us in configuring high available Postgres clusters on Kubernetes. In Vietnam, we are doing this. And then we are looking into Chef combined with Rook operator on top of Kubernetes so that we can have something like elastic block storage for on-premise, our on-premise data center in Jakarta. We would like to thank our friends across the entire organization because this is definitely a compilation of Kubernetes stories within the organization. If you guys have any question, feel free to ask or come stop by. Thank you, China and Shanghai and KubeCon. 谢谢.
Yeah. Any questions? Yeah.
When you're doing the migration, so you are migrating the applications from the VM to the Kubernetes. So there possibly there will some situations that the hyper network that you need to, for example, there is some application in the VM. You need to communicate with the applications inside in the Kubernetes. Sometimes the application in the Kubernetes need to communicate with the applications outside the Kubernetes network. How you solve this problem? Use what technology you are using?
Yeah, that's a very good question because that's the use case that we are specifically facing in our GoPay infrastructure. So as I told you, we were in favor of CNN plugins that could make VMs and containers talk to each other. In this case, in our AWS cloud infrastructure, for instance, we were using AWS CNI plugin so that the pods get the same IP ranges in the VPC. The pods get routing through the AWS VPC fabric so that VM can reach the pod directly and then pod can reach VM directly. As we don't have any picture here, but they don't differentiate that. So this is the exact use case because we are migrating step by step. And we are starting to hit this issue. There are many CNI plugins that can do that, especially, for instance, Calico. Calico, if you configure it properly, you can have routable IPs. If you do BGP peering and all that, you can configure pods to be routable directly to reach the VMs in the same VPC and many other options actually. But again, every team has different option here. For that case, we hit in the service wallet service. We are using AWS CNI plugin.
Is there any
For that case, we haven't migrated 100% workload yet, so we will see that. Probably 20, 30% we have. So far, so good. But with AWS CNI plugin, there's a limitation of maximum route table, I guess, of 50 route table that we will have to overcome soon. But yeah, let's see. Okay, if there's no other question, that's it. Thank you.